All right. Short form naming tests for assessing relative linguistic impairment in chronic or progressive aphasias. I'm very excited to present this material today at this talk. This is a slightly modified, updated version of the talk that I gave at this year's, or I guess last year's, ASHA convention, the American Speech Hearing Association. Um, the the reason I'm excited to present this today is that if you had asked me over, the course of my career, almost 20 years now, why do I make computational models of picture naming and aphasia? I would say, to understand the speech production process. And then I would append a promissory note that says, and someday in the future, a better understanding of aphasia will lead to better assessments and treatments. And if you're a fan of these C-STAR lectures, you're probably familiar with this promissory note. It's certainly one that I've handed out quite a few times. But I'm excited today because we're going to cash that check, and I'm going to hopefully present some things that you will find useful and not just intellectually satisfying. So, um, I also want to start out with sort of acknowledgments and disclosures. Of course, science these days is a team sport. I would not be able to do any of this without my collaborators, who are listed here on the slide. They, collecting data, scoring data, preparing data, recruiting folks, all of this, feedback on all kinds of, what are the important things to focus on. Um, and so that has been just a really great collaboration. So I'm excited to present that. And yes, so as Dirk mentioned, this is working with folks both in South Carolina and in Irvine and San Francisco as well. So, um, disclosures. This is sort of like where I get my funding from. The National Institute on Deafness and Other Communication Disorders, of course, funds the Center for the Study of Aphasia Recovery, which I've been very happy to be a member of, very lucky to be a member of. This is, of course, headed by Dr. Julius Fridrickson. And then the National Institute on Aging funds the Alba Language Neurobiology Lab, at least this part that I have been involved with, and that is headed up by Dr. Maria Luisa Gorno-Tempini. And then, as Dirk also mentioned, I work in the Auditory and Language Neuroscience Lab, headed up by Dr. Gregory Hickok. And so these are the main people who have made this work possible. And as I also get a salary, I just also want to point out that all of the presented short form naming tests are published that I'm going to be presenting, freely available picture stimuli. They can be found out there on the internet. So I want to say that, and as well as we do have this idea in the future to publish and commercialize and market sort of materials and things for these kinds of naming tests. But for now, it's early days, and this can all be found online in articles and such. So let's take a look at what we'll be digging into here. So I want to start a little bit of an overview, probably review for most folks. Talking about picture naming and aphasia, how it's usually used in terms of a unidimensional test score. I want to talk about a new way to measure naming, using this concept of relative linguistic impairment, that you're sort of worse on some parts of language than others. And then we'll look at how we can sort of take advantage of this by modulating response types with a new naming test that we came up with. We'll look at chronic stroke aphasia and progressive neurodegenerative aphasia and how these tests have worked out so far in those cohorts, and hopefully take away some useful conclusions. So, without further ado, I think most people are aware that picture naming anomia is a highly prevalent symptom in aphasia. Some say, pretty much every type of aphasia comes with some sort of anomia. It's very widely reported. This is one survey of symptoms of 88 people with aphasia in Pakistan, and you can see there's a bunch of different symptoms listed here, but anomia is by far and away the most common one. Picture naming tasks have many clinical applications. They're used in several different ways in the clinic by different clinical practitioners. One possible use for this is a proxy assessment for overall severity of language impairment, and we'll talk a little bit more about that in detail. Stroke aphasia recovery prognosis. There may be some information about how treatment and things might work going forward. Treatment outcome studies. I guess I got ahead of myself there. Measuring, yeah, the effects of treatments. Tracking disease progression in primary progressive aphasia, where things are not getting better, but tend to get worse, and we want to know, how the disease is progressing, and also sometimes used in pre-surgical functional brain mapping to identify eloquent cortex that surgeons want to avoid cutting on. And this is a non-exhaustive list. These are just the ones that kind of come to mind off the top of my head. So typically in these situations, we're using a unidimensional score. This is a score that goes up or down. This is your typical test score that ranges between 0 and 100, or whatever the range is. And there's sort of two types of scoring rubrics that will result in this type of score. So you can do a simple incorrect or correct for each item, right? You just say whether did they get it correct or not? Did they name it or not? And then you sort of add those up and divide by the total number, and that gives you a proportion of, how often did they get a correct response. This rubric below here is taken from the quick aphasia battery, and you can see that it measures how close you get to the target, the proximity to the target. So you can be really far away and say nothing. Maybe you get half of the phonemes. Maybe you get it, but it took a little while. And so you can add these up and again divide by the total possible number of points. And this gives you a little bit more information. The gradation in the score is a little bit more fine. But again, it's this, good or bad. You can have higher or a lower score. And this leads to the idea that you can order people, persons, right, in terms of their ability. So there are people who have high scores and there are people who have low scores. Likewise, we can look at the items and look at the proportion of people who get the items correct. And we can order the items in terms of difficulty, in terms of the frequency that people get it correct or incorrect. So this leads to this idea that we can order the items and we can order the people, and that this information, being able to say, oh, this person is better than some other person, or this person is better than the same person was 2 weeks ago. This allows us to do mathematical computations and statistics and assess effects of intervention. This is a non-exhaustive list of picture naming tests that have been developed for aphasia since the 70s. Every 10 years or 5 years or so, we get a new one, and they have different motivations, different theoretical motivations, different purposes, clearly different numbers of items. That's kind of a big one. They have different motivations for why they have these different numbers of items. This is, of course, like I said, this is a non-exhaustive list, and it's biased. I'm on here twice, if you see that. So, there are some computer adaptive short forms that have been developed. The quick aphasia battery only has 6 items, but has that more developed scoring protocol. So, I'm going to talk a little bit about this last one, the severity calibrated aphasia naming test that has come out recently. Just a few years ago, we published this in the American Journal of Speech Language Pathology. And so the severity calibrated aphasia naming test, or the SCANT for short, the point of this was to develop a naming test that gives a approximation of aphasia severity with the fewest number of items possible. And this was not based on any sort of cognitive model. This was based on an observation that there is a strong correlation between naming accuracy and overall aphasia severity. And we wondered whether we could sort of take advantage of that and sort of maximize that. And so we started with 3, and just to kind of illustrate, you need a lot of data to do this. And so we've only really been able to do this by teaming up and working with a lot of folks. So 360 people with aphasia, they each named 175 pictures. That's the Philadelphia naming task. And they also have a Western aphasia battery. And I have this little slider bar here because we're just using the aphasia quotient, which again is this unidimensional score that gives an overall measure of severity. I'm going to gloss over a lot of methodological details in this talk, so feel free to ask me later or look at the papers. But we use lasso regression. Essentially, we assign each item a weight that tells us how important the item is for predicting the aphasia severity quotient. And then we order them by their weight, and we take some n number of items and we just add them up and we use that as our test. And so how do we get this n number of items? What's nice about this lasso regression approach is that we can ask how many items do we need in order to maximize our correlation with WAB AQ. So we're looking for a fixed set of items that yields the best predictions. And so we use cross-validation. Each one of these colored lines, so let me orient you to the graph here. So this is using an increasing number of items in the test. And then this is the prediction error that we get when group level prediction error when we predict the WAB. So lower is better. And each of these colored lines is a cross-validation fold. We did 10-fold cross-validation, and the big black line here is the average. And you can see that this prediction error bottoms out at 20 items. So fewer than 20 items, you're losing information about the overall aphasia severity, but more than 20 items is redundant. You're not getting any benefit from that as far as predicting the WAB AQ with a linear regression. There might be reasons why you might want more items, but for this purpose, 20 items was a nice objective number for us to use. And these, in fact, are the 20 items. And when we look at our cross-validation prediction error, this is using over the whole 360 patients. We're within plus or minus 7 points. You can see there's this diagonal line is the identity line. We're explaining about 83% of the variance in these test scores. So that's pretty good. That is in line with some other ways of estimating aphasia severity in the literature. So we're happy about that. It works, but we have this kind of problem that's been sitting out there for quite a while that cognitive psychologists and neuropsychologists have been telling us that language and speech and picture naming are multi-dimensional. It's not just one monolithic thing. There's multiple steps that go on, and if there are multiple steps that go on, then we can imagine that there are different orderings for those steps. So we have to select a word. This is the Dell model of language, where first you have some idea of what you want to say, these semantic features, and then you choose a word, and then you choose the phonemes corresponding to that word. So you can make errors at any of these levels, and so there might be people who are better at selecting words than other people. There might be items that are easier to select than other items. And likewise, at the phonological level, there might be people who are better at selecting phonemes than others. And so we can order people along these different cognitive operations. Right. So as I mentioned, right, there's this idea that we can order people and items in terms of their lexical ability or lexical difficulty, and likewise for sublexical ability or sublexical difficulty. And this is, I mean, presumably there are multiple cognitive operations. These are kind of the two most obvious ones that people have zeroed in on in speech that are the most tractable. So we'll start there. And we developed a cognitive model. This is a multinomial processing tree model. And this is for assessment of picture naming abilities that can help us to evaluate these different levels in the picture naming process from picture naming data and error type data. And this is a picture of the model. It's essentially a flow diagram, a tree diagram of the process where we start at the root node, and each of these letters or lines or branches is a probability of successfully rejecting competitors until you select whichever word you're going to select, and then you have to select the right phonemes. So there's some probability of success for that. And depending on the combination of errors and successes, we get different types of responses. And the main point here is that this is organized, is that we can evaluate and pull out these probabilities of success at the lexical level or at the sublexical level. And as I mentioned, we can use some item response theory formulas to separate out the effect of people and the effect of items, so the difficulty of items. We did this using a lot of data. Again, you need a lot of data to do this. So 365 people with aphasia, 175 pictured items. That's the same as the Philadelphia naming test as before. And this time we're looking at 8 different response types, not just correct or incorrect. And this allows us to sort out the items in terms of whether they're easy to choose the word. So items like cat or elephant, these are animals that we learn early on in life. They've got distinctive features, whereas things like skull or thermometer have to do with sickness and death. We don't think about them so much. Whereas, but then on the other hand, an item like cat or skull are, few phonemes, pretty easy to put together, where elephant and thermometer have more phonemes and are harder to put together. So we can rate these items in terms of whether they're easy or difficult for lexical or sublexical ability. And then once we've done that, we can find items that challenge a particular level. So they're of course every item is going to challenge both levels to some degree, but one more than the other. And so we expect more errors on one type of item than the other if you are particularly impaired in that process. So folks who have a specific impairment to word retrieval are going to have more more difficulty with an item like skull than elephant, and the reverse would be true or expected for somebody who has a specific phonological problem. And so we did that, and we designed a test to see if we could, in fact, extract these specific impairments, or relative linguistic impairment is what we're calling it. And so here are the items that we found. So we used 20 items from each. That 20 number comes from the scant. And so we use 20 items from each. And you can kind of see right off the bat that these items look different. In fact, and indeed they are. So this is their estimation from the model of the likelihood of a lexical error versus a sublexical error. And when I say sublexical, I mean phonological or motor. We don't differentiate that. Um, and this is to be expected, right? This is how we chose the items. So that's to be expected. It's good that they are indeed, you have a higher chance of a estimated lexical error on the lexical test and a sublexical error on the sublexical test. When we look at other properties of the items, we also see this a difference. These are properties that are known to affect picture naming in aphasia. So the lexical test items have a higher logged spoken frequency, and the sublexical items have more phonemes. But what's really interesting, I think, about this is that if you do a unidimensional model and you ask just on average, are these items more or less difficult? The average person with aphasia performs about equally on these two lists, because the average person with aphasia has, damage to both systems. And so these numbers come from a unidimensional item response theory analysis of the Philadelphia naming test that was performed by Fergatiotis et al. And provides the basis for the computer adaptive test. And so this model does not see these items as different, which is, somewhat important. We'll see later. So we looked at what happens when we give people with aphasia these tests. What comes out of this? And the folks that we looked at first came straight from C-STAR. We conducted the polar clinical trial, and we're not so much interested in the effects of treatment here. In fact, the effects were pretty mild. We're interested in sort of more cross-sectional effects here. So 91 participants with chronic left hemisphere stroke. These were all the folks who had complete data and neuroimaging for the complete item level data. because we needed to do item level analysis. They were 44% female, 56% male, 20% African American, and 80% white, 4.6 years post-stroke. So this is chronic stroke. Um, and we have a breakdown of different aphasia types here. Um, Pretty heavily frontal, a lot of Broca's and sort of frontal motor issues in this group. We also include 12 folks who were recovered. They had strokes, left hemisphere strokes, and some complaints of language problems, but their WAB score was high enough to not qualify as having aphasia. That being said, there are other studies out there who show that these folks do show impairments when you push on their language abilities. So we wanted to see if these abilities might show up in our new test. And as I mentioned, it's a pretty high proportion of folks with apraxia of speech here, lots of frontal damage. So from this group, we collected tons of data, but we're looking specifically at their complete item level PNT data. We then extracted responses from the short forms. So we did not administer the short forms by themselves in vivo to these folks. So that's something to consider. They also had a Western aphasia battery. We looked specifically at their word finding composite score and their repetition composite score. We're going to use those as proxy measures. We also looked at structural neuroimaging, just the lesion mask, that standardized lesion mask in a template space, and then as well as the functional neuroimaging contrast of naming versus rest. And to give us a sense of how to sort of interpret some of these scores, here's some data from 20 healthy controls. This is from the Moss Aphasia Psycholinguistic Project database. And these are spouses of stroke aphasia patient, participants. They are nominally healthy. They're community dwelling people, approximately age matched. So I don't have much more detail on these folks. Beyond that. But we can see that there's this sort of region where folks are falling. Oh, sorry, let me orient you to the graph here. The y-axis here is the scant score. So this is overall aphasia severity, or right, or language severity, and we expect healthy people to cluster near the top, and they do. And then the RLI score, the relative linguistic impairment score, is just the difference between the score on the lexical test and the sublexical test. And if people are about equal on these, we would see 0. So we expect them to cluster around the middle. Interestingly, if folks had some sort of bias towards one of the tests, the healthy folks, it would always was towards the lexical. They found the lexical items slightly more difficult, even though in the ratings of the items, in aphasia, the sublexical items were slightly more difficult. But they basically cluster close to 0. And there was, in fact, one person here who showed up as a significant difference. That's p less than 0.1 using a Barnard's exact test. But so we're going to identify this as the control region. So where do folks from the polar clinical trial fall? Well, clearly, quite a few are outside of that region. We get a spread along the y-axis, so the severity, but also we're finding folks who appear to be surprisingly better on one test than the other, which you wouldn't expect if it was just sort of one sort of naming ability. About 63%, 2/3 almost, were outside the scant control range. So if you're just using the y-axis, just using a unidimensional score, you would identify 63% of this group as being not normal, or for not in the control range. Whereas if we add this RLI assessment, suddenly we're up to 3/4, 75%. And that is significant with one tail P. You might be wondering why one tail P, because it wouldn't be significant if it was two tail. No, that's a joke. That's totally a joke. You can't add a test and get lower sensitivity. So we're only interested in one direction. So that's why it's a one tail P. And then if we look at then we look at who are we had 7 lexical relative linguistic impairments. These folks over here, and most of them were recovered or anomic, so fairly mild. We did have one Broca's aphasia patient who was pretty severe. And then for sublexical, we're seeing mostly Broca's aphasia. And so this is kind of lining up with what we would expect from what we know about these impairments and where we think their impairments are in the cognitive structure. Um, so that was successful. We do find, in fact, there are people both in both directions who find one test better than the other. This was not just a fluke. This was observed consistently for up to 9 months. So over the course of the polar trial, folks received multiple administrations of the Philadelphia naming test, up to 12 administrations over the span of 9 months. And so the graphs here on the left are the full PNT score. The x-axis is the number of weeks into the study, and the vertical dotted lines are assessment points. The gray shaded area is where they received treatment. Again, we're not super interested in that part at the moment because mostly you can see these lines are just trending horizontally. Um, so this is the overall Philadelphia naming test score. Here's the scant score, which is extracted from these items, and so we expect it to approximate these scores, and they do. So they're right. These folks are all pretty good at naming, although we get a little bit more noise. Right, the score bounces around a little bit from week to week. Um, but when we look over here at the RLI score, if this were a fluke, we would be expecting these lines to be bouncing around zero. But they don't. They stay above. And the difference between the top row and the bottom row is that these folks received phonological treatment first. These folks really received semantic treatment first. Again, that's beside the point. These folks are all they're doing better on one test than the other every time you test them for 9 months. You get some noise. This is a noisy score, but it's not any more noisy than the scant score. So they're both on the same scale of 20 items. So and then that's for folks who have this lexical impairment, and then we find again same thing. These folks have more severe overall impairments, but consistently finding the sublexical test more challenging over the span of 9 months. Um, so that is encouraging that this is a real feature of their aphasia. Additionally, it's not just picture naming. We can see these effects in other language test scores, and so these effects are predictable based on other language test scores. We said if this is a real thing, if this is a real part of your aphasia, we should be able to measure other ways of measuring lexical or sublexical ability and find that it relates to the test score. And so we did that using the word finding score to approximate lexical ability and the repetition score to approximate sublexical ability. And as I mentioned, so the hypothesis is that if there's a difference greater than 10%, that's based on the variance in the scores, that this is, a unusually large difference, then we should observe, again, a similar difference between the lexical and sublexical naming test scores in the corresponding direction. We were able to find 11 participants in our cohort who were better at word finding than repetition, so they're repetition impaired, and 30 participants who were word finding impaired. They were worse at word finding than repetition. And we do a two-way ANOVA, and we find this classic crossover interaction. It is significant. And thank you very much to a reviewer who pointed out that the first time I did the ANOVA, I was not doing it, repeated measures. So this is a repeated measures two-way ANOVA, which makes it significant. And so you can see that the naming test score, the overall accuracy, depends both on the type of impairment and the type of items. So we can't just say that, oh, these items are easy or these items are difficult, because for this group, these items were easier than these items. And for a different group, the same items, right, you get the reverse pattern. So it really depends on the impairment about which items you're going to find more difficult. Contrary to the unidimensional model here that is often used. Um, we found that these significant effects were associated with characteristic lesion patterns. This is not a super formal analysis; it's rather informal, where we just kind of eyeball these patterns. But you can see that most of these lesions are medial. They hit medial white matter and spare most of the parasylvian areas. This first one is a bit of an exception, although that was not a consistent um, RLI. Um, on the other hand, these sublexical impairments were yeah, came with huge lesions that hit the um, most of the Parasylvian language area. Um, Again, these patterns are not sufficient on their own to explain these effects. We have patients who have these lesions and don't show these effects. So it's not clear exactly what it is that causes this, but there does seem to be a difference there, some real biological difference. And this as well, we find the effects in activation. So when we look at brain activation and we try to predict which areas are going to be active during picture naming, more active than rest. On the left, we're looking in each region of an atlas and we're just using a linear regression, multiple linear regression using naming accuracy as one predictor. And these are the significant regions where so increased accuracy leads to increased activation in Parasylvian regions. I don't think anybody's surprised by that. Some of these decreased areas might be default mode network type things. But that's, pretty standard stuff. I don't think anybody's too surprised about that. But what is interesting is that there is this additional independent effect of the RLI. So after you've accounted for accuracy, the more trouble that somebody has with the sublexical test, the more they're activating their dorsal stream here. And likewise, the more trouble that they have with the lexical test, the more they're activating their ventral stream here. And the idea is right. That's in order to achieve the same level of accuracy, these folks have to activate these regions more than another region. So that's pretty exciting and interesting that we can see these brain network differences that line up with the sort of dual stream model that motivated this separation. Okay, so where are we at now? This is the interim summary, and this all this data has been published. Um, so relative linguistic impairment in chronic stroke, it's measurable. We can measure this by comparing accuracy scores on different types of items. No errors type scoring required. These effects can be stable for long periods of time, months, and these effects extend to other language test scores, structural neuroimaging, and functional neuroimaging. So this does appear to be, excuse me, a legitimate feature of some people's aphasia. So what about other neurogenic causes of aphasia, right? Like neurodegeneration, primary progressive aphasia. Um, these items were all calibrated using a stroke cohort, so we don't know. Will the items be difficult in the same way for people who have different source of the language impairment? There's nothing in the model that suggests that the difficulty um, is related to stroke per se. It's just sort of these items have difficulty and they range over um, some range. So maybe it'll be the same. Um, we don't even know if the patients would be able to comply with instructions and complete the task. There's a lot more behavioral and attention issues that come up in neurodegenerative conditions. And we want to know if different variants of primary progressive aphasia exhibit different naming behaviors because there are these theories that these different aphasias are impacting different processes in the speech production process. So we have non-fluent aphasias that impact sort of sublexical things and semantic aphasias and that affect semantic things and logopenic aphasias that somewhere in the middle. So we want to know if this works, and this was the first time that we have applied these that will apply these items in vivo. And so to test these ideas, we teamed up with the Alba neurobiology language neurobiology lab. Is run by Dr. Gorno Tempini and Dr. Miller as well. You can see them there, and they're at University of California, San Francisco, and they have just an amazing apparatus to collect and recruit and collect data. And so within, I think we've done a year now, and we already have 108 patients with neurodegeneration. Um, they were all 1 to 3 years post-diagnosis, so pretty early in the process. Um, and they all receive this very large language and cognitive testing battery, both for clinical purpose and for research purposes. And so we were able to sort of piggyback onto this this protocol, and we had two ASHA certified SLPs administer the scant and the RLI short form naming tests. I didn't mention, so you might be doing the math like, okay, 20, 20, 20, that's 60. There's two items that overlap between the scant and the sublexical form. So we only administered 58 items, and we double count those two items, but we're counting them for different scores, so it's okay. And here's the distribution of the breakdown of different types. We're up to 15 non-fluent, 10 logopenic, and 9 semantic PPA. We also get a lot of frontotemporal dementia, both the behavioral and the semantic variant. And then this other group includes Alzheimer's disease, mild cognitive impairment, some palsy, um, and so kind of just general neurodegenerative diseases kind of fall in that catch-all basket. So here's how the folks with neurodegeneration fall in that sort of two-dimensional space. They tend to be higher, less severe than the folks with chronic stroke, because as you know, they're early in the disease. But we see there are plenty of folks falling outside this control range. Again, if we do that comparison where we're just using a unidimensional score, only 30% of these folks would show up as having some sort of abnormal naming. Whereas if we add this new test, suddenly that jumps to 44% of these folks who have a diagnosed neurodegenerative condition have apparently abnormal naming. And that's, again, significant. Um, mostly these folks are, again, falling in the lexical side of things. Here's the breakdown, kind of a wide range here, but largely logopenic and the behavioral FTD. Are represented there. And then we only had two of these sublexical folks, one non-fluent and one MCI. This non-fluent participant, I want to point out, this is an extreme difference. This person did all of their naming written. They had no verbal output, and all of the naming was written, but it was striking. It had lots of phonological errors and spelling errors, and looked like what you would expect from sort of a broca or non-fluent patient who spoke the naming. So we are going to exclude that participant from some of our later analyses. Just a heads up. Okay, so how did the administrators of this test feel about administering it? I was finally able to create a test and put it out in the wild and get feedback, and so I'm happy to share that with you. So they said that the task is quick and easy both to administer and score. Providing the answer helps to prevent frustration and perseveration for the patients. That's actually a feature of the Philadelphia naming test that we ported over to this. Not having a queuing hierarchy like you do in the Boston naming test, for instance, it saves a lot of time and frustration. The items are much more commonplace. The Boston naming test has items like weather vane and abacus and trellis and things like that, where people miss these items for reasons other than their aphasia. So for these items, we're more confident that the errors are really errors. The task seems sensitive to those with subtler word retrieval deficits, including due to executive causes. And we saw that a little bit before in our data, that there is this increased sensitivity. There's a lot more items and more data than from the quick aphasia battery, which only has 6. So it's really helpful for SLP insight into impaired confrontation naming on our existing language battery, especially since the neuropsychologists administer the other naming tasks, so the short form BNT or the MINT. And the takeaway for me here is that they already have this massive language and cognitive battery, and they are still finding this test to be useful, and like it is a useful addition that can help SLPs see what's going on a little bit better. And so that made me feel pretty good about this tool. Um, the elicited error patterns cover the full range of semantic, phonological, circumlocutory, and dysexecutive error types we would expect from each variant. So remember, we were focusing only on accuracy, but these, great SLPs, very observant, were keeping track of these things and saw that the error types are also useful and diagnostic on this test. So here are just some examples from logopenic, aphasia of typewriter to tyking, broom to brush. Um, Semantic examples, you get circumlocutions, semantic loss, so a vest, it's like a shirt, but it doesn't have sleeves, superordinate categories, general superordinate categories, within category, pear, onion, non-fluent, this is all sort of motor speech type stuff, necklace to neckless, calendidar. So behavioral variant, FTD, frontotemporal dementia, they are also having interesting errors that look actually kind of like the logopenic errors. So thermometer, temperature taker, binoculars, binoculars, pear, apple. Um, and then as well as disexecutive. So typewriter, no, it's an umbrella. No, you type on it, it's a typer, typewriter. But they said umbrella impulsively for everything else. And then a cloud, it's a cloud, not a cloud, but liquid coming out of the ground. And they just kind of do this description, kind of train of thought. Um, Okay, so speaking of these error types, that got me thinking, hey, maybe we should look at these error types and see, we said that these tests should be manipulating the likelihood of different types of errors. So let's see if that happens. And so this is looking at all the participants except, the one who had the written naming because it was a bit of an outlier. And indeed, so here's the we I did a very simple sort of scoring of just four types. So description, if it was clear that they knew what they were describing, unknown, if they just, sort of said, I don't know what that is, or had no response. Semantic, if they provided a category coordinate or superordinate, um, and phonological is if they have most of the phonemes, but there's some sort of mix up of the phonemes to create a non-word. Um, so we see, and let me back up. So the scant errors are here on the left. The scant errors tend to be low. So high bars mean more errors. So that's poorer performance. So the scant, it tends to be a little bit easier than these other two tests, which are designed specifically to challenge one process or the other. And we see, in fact, this is a highly significant difference in the terms of the number or proportion of semantic errors that we observe on one test versus the other, and likewise a smaller difference but still significant between the phonological errors. These tests do seem to be pushing these errors around. But that's with everybody. But when we look at these specific groups, remember we expected that there would be sort of differences in the sensitivity and the types of errors that they would make. So for non-fluent, um, we find that regardless of the type of items, they're making mostly phonological errors. We do get this successful manipulation where they do make more semantic errors on one versus the other, but despite that, as a group, this is a group level analysis, they're making more phonological errors. The semantic folks, likewise, are making more semantic errors. If you sort of ignore the description and unknown ones, which also are obviously much more common in this group. But between the two, semantic or phonological, the semantic PPA, this is a characteristic error type that it seems to persist, beyond this manipulation. And interestingly, the logopenic folks show this high level of sensitivity as a group. So the semantic they make more semantic errors on the lexical test and more phonological errors on the sublexical test. And so we do see that there are these group level patterns to these different types of variants of progressive aphasia. Interestingly, and I don't want to make too much of this because we're still trying to figure this out, but we did see that there are different naming profiles even within a group of folks who all have the same diagnosis of logopenic primary progressive aphasia. These two folks up here had more errors on the lexical test, and you can see the quality of the error is semantic and description. Whereas this person had more errors on the sublexical test. And again, the quality of the errors changes to phonological and unknown. And so again, we're not sure what to make of that, but the point is that we're seeing differences that we didn't see before. And that is interesting. We want to figure that out. So let me wrap up here and maybe we'll have just a few minutes for questions. So takeaways. So naming accuracy in chronic and progressive aphasias, just accuracy, depends on the type of impairment of the test taker and the type of items on the test. So we can't just say these items are hard and these items are easy. We need to consider the impairment of the test taker. And this is a sort of warning that apparent changes in accuracy can be due to changes in the property of the target items. Most of the time, 9 times out of 10, that unidimensional model will work just fine. The computer adaptive model will work just fine, but sometimes it could give you two sets of items where you see a low score in the beginning and a high score in the end, and it's because you were challenging a specific disability in the beginning and not challenging it at the end. And so despite the score change, there has not been a change in the underlying aphasia. So it's just a bit of a word of warning. And so the idea here is that you can use this test as a quick sort of check to see if maybe there's something wonky that you might have missed. Um, Naming response types can be modulated by different types of target items. I think that was already known, but we were able to really, I think, demonstrate that nicely using this cognitive model to select the items rather than based on the features of the items themselves. Um, this new test is appropriate for chronic stroke and neurodegenerative patient cohorts. We just recently had our first participant who was unable to complete and it was somebody with behavioral variant FTD, and they were unable to complete the test. But out of 108 people, 109 people, that's pretty good. That most folks found the test to be enjoyable even. Um, Significant RLI effects were relatively infrequent across etiologies. So, as I mentioned, most of the time this unidimensional model works. Most people do have, when you have a stroke, these strokes don't respect these functional boundaries very well. So they hit both networks. But every now and then, about 12% in both cases, in both cohorts, it was about 12%. We find these folks who have clearly a problem with one type of naming item than another. And these, right, as I mentioned, they're chronic and observed across an assortment of data. So it's not just picture naming. This is a core feature of the aphasia. Um, and so finally, responsiveness to this target property manipulations may provide diagnostic information. We need to suss this out and do more research and figure out exactly when this is useful, how this is useful, how can we target treatments if that's even a possibility. So there's still more work to be done, but we're optimistic that this will in fact, like, you can take this and use this now and help us to try to figure this out. And so, as I mentioned, so for future directions, we want to calibrate more items, expand our pool of items to make more tests, maybe uh, matched tests. We want to explore these clinical applications and collect user feedback. So the more that folks can take this up and use it and tell me that it's wonderful and it works, or it's horrible and you never want to use it again, all of that feedback would be really helpful for us. So with that, I will conclude and I'll take some questions.
Thank you so much, Grant. That's great. That was a really nice talk. Thank you. So I'll applaud for the audience.
Thank you.
We have some questions online. I want to start with a question by Lynn Kutev. Um, does presence or absence of apraxia of speech map onto sublexical or lexical leaning RLI respectively? And as a follow-up to that, how did the proportion of people with apraxia of speech in your neurodegenerative cohort differ from your stroke cohort?
Hi, Lynn. Those are great questions. The first one is yes. The proportion. So how can I say this? There is a significant relationship between the presence of apraxia and having a sublexical impairment. And there's several ways that you can, address that, and all of the different ways lead to that conclusion that yes, there is a relationship between sublexical relative linguistic impairment and apraxia. So, um, as far as apraxia in the neurodegenerative cohort, I don't know. That is a good question, and I'm not sure. I Yeah, I'll have to go back and look at that data and ask the folks in San Francisco.
As a follow-up as well, Grant. So it seemed to me, and I may have misread that. So it seemed to me that you had non-fluent neurodegenerative patients, that
Correct.
they had less of a difference in their um, sublexical errors, phonological errors between the lexical and the sublexical items than the logopenic patients who showed a clear difference with making more errors on the sublexical items. Is
Yes.
that correct? And if so, if that's the case, do you think that indicates that first of all, that there's a difference, of course, which we kind of know or assume, between the nature of the non-fluency or the phonological or phonetic impairment in non-fluent PPA versus logopenic PPA, where the logopenic PPA seem to be more sensitive to actual phonological structure. Would that be a fair
Yes. Yeah,
assessment?
yeah. Yes, I completely agree with that. And right, and right there it's sort of there sort of has to be, especially it's striking that the non-fluent folks continue to make these phonological errors on the lexically challenging test, whereas suddenly that challenge goes away for the people who have logopenic aphasia, and suddenly they're making semantic errors instead. So yeah, there's something there. There's clearly a difference there. I would agree.
That's super interesting. So, a related question by Maya Henry. Great talk. Sorry if I misunderstood this, but did you say that what seemed to be motor speech versus phonological errors were both classified as phonological? Since some of the non-fluent variant PPA cases are relatively purely apraxic PP AOS, no significant aphasia, and most have some degree of apraxia, a significant proportion of these are likely more motoric than what I'd consider phonological in nature.
Absolutely, yes.
Lengthy
And
question.
that's
She
why,
goes on.
yeah.
Should
Oh,
should you maybe be referring to those as articulatory phonological errors or something akin to that? Admittedly, it is very difficult to disambiguate these errors in individual patients, but I do think if we're attempting to understand mechanism, it may be problematic to conflate these processes, particularly if we aim to inform intervention. That was me channeling Maya.
yes, yes, absolutely. Thank you for that question. That's a great question. And yeah, so this is why we use the term sublexical, to your point about should we call it articulatory phonology. So we settled on this term sublexical as sort of catch-all for anything, past the word, the full word. And you're right. This is an issue. It always comes up when we talk about this. We are conflating these things. Um, it is, we're kind of starting out here. This is kind of low-hanging fruit. We're trying to, carve the world at its joints, as they say. And so it's much easier to separate out semantic and non-semantic, these lower level things, than it is, as you pointed out. So we have started to look at this. We do have a a multi-nomial processing tree model that actually separates out those two levels of phonology and motor, and we're finding some interesting things. But one of the takeaways, as you sort of hinted at, is that when you look at items that are difficult for somebody with a phonological impairment and items that are difficult for somebody with an apraxic impairment, they're the same. It's largely the same items. There's a lot of overlap. Something that's going to challenge phonology is also going to challenge apraxia, and vice versa. There are we found one or two standout items, but just using the pool of items that we have on the PNT, we weren't able to do this sort of exercise where you can find items that specifically challenge one process versus another. This is one of the reasons why we want to calibrate more items and sort of expand this approach. But for now, yes, this is potentially a problem if you're trying to sort out the mechanisms sublexically. Absolutely, yeah. There's more work to do there for sure.
Yeah, it also seems like for that you really would want to look also at the kind of not just which items do people make errors on, but what kind of error do they make, right? And
Absolutely,
that
and
and
right.
even what does that look like? Because
Right,
that's
and time, right, like timing and things like,
yeah.
right, the timing of the response is very important for apraxia and things like that. So yeah, there's lots more to do here. I think there's a lot more that can be done. But at least as far as what we were aiming for here was to this is really just sort of it was motivated on the one hand as a just a validation of our MPT model, which is to say, hey, if it's really the case that picture naming is multidimensional, we should be able to observe that in just the accuracy score without looking at error types. And so we do, and then it's also kind of nice to not have to transcribe and score errors. The idea is that this could be a very quick type of assessment, to kind of do a screener to see if there's any, targeted impairments.
Great. And Maya says, thank you. That makes sense. So, um, I had a question as well. It seemed to me that, so that's just an observation from looking at the items that you showed, right? Um, that the shorter, that the lexical items, which are also shorter, may have more naming competitors
Absolutely. I
than.
believe that is so. So yeah, so this is another. Sorry, I didn't mean to cut you off.
No, that's fine.
But
Well,
yeah.
so if that's true, do you think that that can contribute to this finding that you had, where people who are controls actually, if they did make errors, they made errors on those lexical items, which I wonder if those are errors where people are trying to be cute, right? Or which sometimes happens.
Mhm.
Wait, and there's just more opportunity for those lexical items to give an alternative word, which could be acceptable in some ways. Actually, Will Hula responded to that. He says I don't know anything, and he said no. He says I'd argue that in the context of a typical testing session, saying kitty for cat probably does represent an error. Because I said, what if someone says kitty for cat?
Mhm.
That's not really an error. It's just someone trying to be smart, right?
So
And he
instead
said,
of
no, it's
calling
an
it, we might, so we one so this is a this is uh, a core, anxiety I've had while scoring Philadelphia naming tests over the past however many years I've done this. And yeah, you feel bad when you like a commode for toilet. That's brilliant. Like that is a great word. Or locomotive. Wow. But it is abnormal. So if it's not an error, we can say it's abnormal, because healthy folks, I mean, 100% of the time will say, or well, like, I guess obviously no, not healthy folks 100% of the time. Most of the time, right? We can say that this is sort of a not a normal response. Um, and so as far as what is driving these, like what makes one item lexically challenging or sublexically challenging, what's kind of fun about this approach is that we're estimating this directly from the naming data itself, as opposed to going the other direction that people usually go, where they say they look at features and try to figure out, okay, given some features, now we can figure out which items, are challenging. We go to the data first and then work backwards. And so it's not clear from just this analysis. We kind of have to do what you're doing and look at these items and speculate and guess and say, well, this might be what is causing that. It is difficult, I will say, to find a good measure of the number of close competitors for a naming item, right? I've tried several different ways to do that, and some work better than others, but it's not like the relationship between the number of phonemes and a phonological error.
right. Yeah, I totally get you. Just a comment from Lynn, which you may want to address as well. She says maybe we need a supralexical node in the MPT too.
Yes, yeah, yeah, especially for the neurodegenerative folks. This model, the MPT model, and of course this test were all based on Gary Dell's two-step model, and that was specifically addressing aphasia, stroke aphasia, where the assumption was that semantics and executive function are largely intact. Which, that assumption, may or may not hold in a lot of these cases, especially the degenerative case. So yeah, I absolutely agree. There's plenty of room to expand these models. That you need, the more you expand the model, the more data you need, the more scoring you need to do. And so we wanted to start simple here, but I love that all these ideas that are generated from this. I totally agree. This is not the end of this approach, I don't think. I think there's lots more to do here.
Great, thank you. And on that note, I think we've reached the end of the question session, and that means the end of the C-Star session for today. Thank you so much, Dr. Grant Walker, for your talk. We're looking forward to your next C-Star talk in a in a few years, maybe. And for now, in 2 weeks' time, Um, I hope everybody returns to us when we'll be listening to Samen and Nemati. So until then, stay safe. Bye.
Awesome. Thank you.